This video is intended to give you some background on the topic of the H-infinity deconvolution filter journal article that we're going to deconstruct to talk about organization of journal articles. Now, a typical way to represent an engineering system is it's sort of a black box. So here's our system. It can be, for example, some electrical circuit. We can think of this system as having some input, U of t, and some output, Y of t. So for example, a simple voltage divider can be represented this way. Here's a voltage source, 5 volts. If I apply that voltage across a series combination of resistors, where the two resistances are the same, they're both R, and if I choose as my output the voltage across this resistor, this voltage is just going to be 2.5 volts. So we have some input, U of t, which is provided from outside the system, and that gives us some output, Y of t. In this case, both of those are constants. So our system transforms some type of input into some type of output. Now the easiest way to analyze this type of setup is if you're given the circuit, so you're given your system, you know the math that relates the input to the output, and you're given U of t, you want to find Y of t. This is an analysis, and it's relatively easy. There's a couple of other things you can do with this type of setup though. So for example, we can be given U of t and Y of t, and we can try to figure out the math that governs the circuit. So find the system from an input and an output. This is called system identification. And this is harder than this. The other thing that you can do with this is, say you're given the output, Y of t, and you know what the system is, and you want to determine the input. This is called deconvolution. This is the hardest. And what makes 2 and 3 difficult is actually noise that gets put in anytime you make a measurement. So if you have your input to your system here, U of t, and your output is Y of t, you never get to actually see what Y of t is exactly, because you always add noise to the system when you measure something and you get some noisy output, say Y sub n of t. And it's hard to tell what parts of Y sub n of t are actually associated with Y of t and what is something that's just coming in from outside of the outside world. So both of these require you to somehow get rid of n of t without knowing what it is. Now there's another aspect of this paper, which is non-destructive evaluation, which is abbreviated NDE. And in fact, in this paper, we used ultrasonics. And the premise is that we have some kind of material here, say an airplane wing. This project was of interest to Boeing. The composite materials are made up of different layers. If you have a D-bond or an air bubble between a couple of layers, that totally ruins your strength. The problem is you can't necessarily find this without cutting the material open and looking for debonding areas. So what we do is put in a wave, an acoustic wave. When you apply an acoustic pulse to something, it tends to propagate through that system, and if the impedances on each side of these layers are different, then bits of that will get reflected back, and eventually they'll bounce around inside here and you'll get your through transmitted waveform. And this waveform has information about the material properties inside these layers and information about the bonding between the layers. Unfortunately, everything's also jumbled up. You have to try to recover the individual information associated with each layer. That's the problem here. We're using deconvolution methods to try to examine this guy here and reconstruct how this original pulse propagated through this system, and identifying the material properties in the layers and the potential d-bonds between the layers. Now, H infinity, I don't really want to talk about very much. Essentially, whenever you're doing some filtering, you're trying to minimize some kind of error. So we want to minimize what would be called the energy in an error. Now, there's lots of ways to do that. Generally, they're based on different definitions of what energy is or how you want to calculate the error. This is one way of approaching this minimization process, which has some advantages and it has some disadvantages. So that's a quick heads up on what the contents of the report's about. Next, we'll talk about the report itself and how it's laid out and how it's written to try to give the information to its audience that it needs to give.